Okay, we are going to do the second half of 1.4, and that is still solving equations, but we kind of get away from getting a numeric answer into getting the actual uh, solving for a variable. So we're going to talk about literal equations here, and a literal equation is an equation that uses at least two different letters as variables. So there's going to be multiple variables in here, and we're going to be solving for one of those variables. So we're going to look at an example here. And again, this is where you really have to understand what variable you're solving for and what operation is being done to that variable. So if we look at this literal equation here, we're going to create an entire new equation. We're not going to get like y equals 2. We're not going to get a numeric answer here. We're going to create a new equation. So I have solved the following equation for y. Okay. So I need to look at this variable y right here. Okay, what is being done to that y? Well, I have a negative 5x that is outside, so that negative 5x means that we're subtracting that. So I need to do the inverse of subtraction, which would be to add 5x to both sides. Okay, add 5x to both sides. So my 5x's on the left here are going to cancel. That's going to leave me with a negative 3y is equal to, I cannot combine 27 and 5x because they're not like terms. So I'm going to write it as 5x plus 27. Again, I think of literal equations as just rewriting them with a different form. We can't actually combine them because they're not like terms. So now I look at this and it reads negative 3 times y. So what is operation is the negative 3 doing to the y? It's multiplication. Inverse of multiplication is division. So I would divide both sides by negative 3, and I do the math I can. I would get y is equal to, I can't do anything with this fraction, so it's going to be a negative 5 over 3x. And then I can divide these two numbers because it's just a 27 divided by negative 3, and that would give me a minus 9. This should look very familiar to you. It's something that we're going to use down the road. That's slope-intercept form. So if you know slope-intercept form, you recognize the y-intercept is negative 9. The slope is negative 5 over 3. That's kind of in next chapter, but it's something that we will get into. Okay, so here's a simple problem where you have k equals c plus 273. I want you to get the c by itself. So what operation is 273 being done to the c, and it's being added to, so we're going to do the inverse of, which is subtract 273 from both sides. When I subtract 273, I simply just write it as k minus 273 is equal to c. This is my new equation, and I have c all by itself. So again, the goal in these problems is try to get c, or the variable we're asking to, by itself. So we're going to look at a problem that's a little bit harder here. Okay, so for this one, I want to solve for y. So I say it's harder just because of the way that it looks. Okay, so this says x minus 3. That has we have no issues with this over here because there's no y. Okay, so for that problem right there, there's no y, so I don't need to mess with that side at all. I need to look at the right side. And where is the y? The y is in the bottom of the fraction. So I have to get rid of that y. So how do I get rid of that y? I'm going to multiply both sides by y. Multiply both sides by y. Okay, so on the right, what does it do? It just cancels this y. On the left, it's going to leave me with y times x minus 3 is equal to 4 plus x times z. So again, it canceled the y here on the right, but it created a y on the left. Now, what is this y being done to this x minus 3? If I were to solve this, I would distribute it, right? But I'm trying to get this y by itself. So distributing is the same thing as multiplication. Inverse of multiplication is division. So I would divide both sides by x minus 3. I know it looks like a mess, but I'm left with, because this cancels, I'm left with y equals 4 plus xz all over x minus 3. You can leave the x minus 3 in parentheses if you want. It doesn't matter. But again, I got y by itself. I created a new equation. It's a bit of a mess, but my goal was to get y by itself. Okay, let's take a look at one more literal equation. This equation I call an advanced problem here. It's all letters, and we're trying to solve for b. And the difference between this problem and the other three that we have done is there are two b's. I'm trying to get b by itself, and there are two b's. So the first step should be really simple. It has to deal with this EF over here. Okay, this EF. I'm adding EF. The inverse of adding is subtraction. So I'm going to subtract EF. Whoops. Whoa, hold on a second. Hold on, let me erase that. That's a bit of a mess. Okay, so I'm going to get rid of that EF by subtracting it. So we're going to subtract the EF from both sides. Okay, and again, they're letters, they're variables. We don't know what number they are yet, so there's nothing I can do with them. So I simply just rewrite A minus EF is equal to B. Whew, C, that's a B. That's a bad B, but it's a B. BC plus BD. Okay, so now here's the question I would ask in class. How do I turn two B's into one? Okay, and this kind of goes back to the end of Algebra 1. I can factor out a B. On the left-hand side, it's going to stay A minus EF. On the right-hand side, when I factor out a B, remember, I'm dividing each of these by B. So when I divide each of these by B, I'm left with a C plus, this B would cancel, D. Okay, so now just like that last problem, now I'm trying to get this B by itself. So I turn two B's into one, okay, by factoring it out. Now I'm going to divide both sides by C plus D. Again, I'm not doing any math here. I'm just showing what I would do if I knew what these variables were. A minus E times F all over C plus D is equal to B. And I now have B by itself, and that's my answer. A minus EF all over C plus D is equal to B. So again, the key is to get that variable by itself. These can be tricky, but again, we're just using inverse operations. And if they're not like terms, I can't combine them. So I literally just rewrite a new equation. Okay, so we're going to have some problems, some literal equations that I'm going to have you practice. We're going to get into some word problems here. With word problems, in all honesty, it's the setup. And this problem comes straight from our textbook. Says flower carpets incorporate hundreds of thousands of brightly colored flowers, as well as grass, tree barks, blah, 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 blah. None of that matters, okay? The flower carpet shown here from Grand Place in Brussels, Belgium, has a perimeter of 200 meters. What are the dimensions of the flower carpet? So we're talking about the perimeter here. That should be an elementary school question of how do you find the perimeter of a rectangle? And that's add up all of the sides, correct? So what are the two sides here? Well, they give us one side as 3x and another side as x. Okay, well, we can't forget this is also 3x over here. So this is 3x, and this side over here is x. So if I'm going to add up all of the sides, it would be x plus x, that's this side, and this side down here, plus 3x plus 3x, and they tell us the total perimeter is how much? 200. Okay, so I have an equation here where I have x plus 3x is equal to 200. Okay, so then I'm going to combine like terms. 1x plus 1x is 2x, 2x plus 3x is 5x, 5x plus 3x is 8x. So I have 8x is equal to 200. I'm going to divide by 8, and that's going to give me x is equal to 200 divided by 8 is equal to what? 200 divided by 8 equals 25. So I get x is equal to 25. So it asks for the actual perimeter. Okay, don't forget that's just this x. So the length here, okay, or the width is 25. So I would get 25 meters and 75 meters. How did I get 75? I did 3 times 25, and that gave me 75. Okay, so again, when doing these problems, it's all about setting up an equation. So here's another word problem that we're going to look at, and we're going to do here. It says find 3 consecutive integers whose sum is 228. So I need to find 3 consecutive integers. What does consecutive integers mean? It means if I start with 2, then 3, then 4. They're numbers that are right next to each other. So 2 plus 3 plus 4 would be 9. Now I could go through the order and just start guessing 50, 51, 52. But what I'm going to do here is I'm going to let x equal first integer. Okay. So I'm going to let x equal the first integer. If I let x equal the first integer, how did I go from 2 to 3? I added 1. So I'm going to let x plus 1 equal the second integer. And I'm going to let x plus 2 equal the third integer. So no matter what I let x equal, if x is 20, then the next integer adding 1 to that would be 21, adding 2 to that would be 22. So now I can write my equation x plus 1 plus x plus 2 is equal to 228. That's what I want it to equal to right there. So again, where did I get the x from? That's the first integer. Where did I get the x plus 1 from? That's the second integer. X plus 2 is the third integer. So now I combine like terms. 1x plus 1x plus 1x is 3x. 1 plus 2 is 3 is equal to 228. So now I have a simple two-step equation to solve. I got 3x is equal to 225. I'm going to divide by 3 here, and I get 225 divided by 3 is equal to 75. So I get x is equal to 75. So that's the first integer. Make sure you answer the question. What are the three integers? 75, 76, 77. Okay. So there'll be some word problems that I might give you in a Google form or in the Delta Math assignment, but that's the second half. It gets a little bit trickier because we're dealing with equations where you have to solve for a variable, okay, again, called a literal equation. And then we also have some word problems here. But again, it's all solving equations. And again, when you have a word problem, the key is what you don't know, you let equal x. And that's kind of the key there.